Hello, good morning everyone. Today we are going to present proposal of our autonomous maze solving robot with Arduino. Um, our challenge is to design a robot that can autonomously navigate a maze, avoiding obstacle while staying within 150 ringgits budget, and the goal is to finish the maze in the shortest time. Our objective is to design and build a maze solving robot using Arduino, infrared sensors, motor, drivers, which I will be explained in the next slide. The robot should autonomously detect path and obstacle to solve the maze, which about 30 centimeters track width, 7.5 centimeters wall height. And then this is the key component. There is seven total, which all of them costs about 150 ringgits. Um, our robot use Arduino Uno as the main controller. It processing sensor data and controlling movement, and it will powered by two 5-volt DC uh, gear motors, which provide reliable torque for smooth navigation. And then the third part is L298N motor driver module, which is will manage the motors, allowing forward, reverse, and turning motion. This is the others part, which is chassis, wheels, and bracket. Uh, it will give the structure and mobility to the robot. Uh, for obstacle detection, we use four-way IR tracking sensor to detect lines or edges, and an ultrasonic sensor to measure uh, distance from wall and avoiding collision. And the last part is the power supply, which supplied by 18650 battery box. The battery will be this will be the housing for the batteries. Uh, this also which will provide stable voltage to run the entire system efficiently.
Hello, my name is Tham HB23018. Uh, Now I want to talk about our circuit diagram and design for our robot car. In here, you can see this is our wiring configuration of our infrared sensor to the four-way module, tracking module, and to the Arduino board. As you can see, we have four infrared sensor arranged in a line, and each of them is responsible to detecting either a black line or a white surface when it's navigating through the maze. The infrared four-way tracking module or the IR module is connected to the Arduino at the port of 8 to 11. Each of the port or pin reach the output from an individual sensor. 1, 2, 3, 4. Okay. This variant diagram shows how the infrared module is connected to the Arduino board, which ensuring proper power supply and data input. Summarize, when the infrared sensor detects a black line, it will send a signal to the Arduino board, and based on which of the sensor either 1, 2, 3, or 4, it detects, the robot will adjust it adjust its track or direction to stay aligned with the path of the black line. So this is what allows the robot to follow the maze accurately. Next, our robot car also consists of ultrasonic sensor, and our robot car having 4 motors. The module for our the motor module is used to control our 4 motor, which is a 5 volt DC gear motor. Two left, two right. This act as a driver to allow us to control the speed and the direction of each motor. The driver module is connected to the Arduino board at from 2 pinu. Here we got our supersonic sensor connected to the Arduino board and the motor driver. The motor module L298N connected to the Arduino board. The supersonic sensor is used to detect the obstacle or the wall of the maze in front of the robot car. The supersonic sensor will send out a sound wave to measure how long it they take to bounce back from the wall to the supersonic sensor. So this can help the robot to calculate the distance between it to the wall of the maze. So when the obstacle or the maze wall is too close, the sensor will alert the Arduino board to send out a command to either stop the motor or change the robot direction. Then here we got our motor module. It's used to control the movement and the movement, speed, and direction of our 5V DC gear motor. Using the driver, we can independently control each of the motor individually, like the motor 1 move and motor 1 and 3 move, while motor 2 and 4 stop, so it allows the car to change direction. The supersonic sensor is connected to the Arduino port at 12 and 13, while the motor module is connected to the Arduino board from port 2 to port 7, as you can see here. And in short, this diagram shows the full wiring layout between the Arduino with the supersonic sensor and motor module. Each of the parts play an important role to allow the robot car to move and avoid the obstacle intelligently and allow it to pass the maze. And thank you, and I pass it to another one.
I'm Cheng. My metric number is HB20016. For now, we will talk about the voltage analysis of our motor control system using the L298N motor driver. For this, in this picture is the schematic of the L298N dual hex bridge motor driver. It controls two DC motors, which is the motor A and motor B, by using the logic signal from the Arduino. In this picture, there is some words that in short forms such as IN1 to IN4, which is the control inputs that set the direction of the motors. And for the ENA and ENB is to enable or disable the motors. However, for the out 1 to out 4 are the output of pins connected to the motors. And for the VD1 to VD8 is the flyback diodes, which is used to protect the circuit from voltage spikes. And for the C1 to C4, which is the capacitors to help reduce electrical noise. For our setup, we assume that power of the driver is using the 12 volts and the motors A is connected to out 1 and out 2. For the motor B is connect to the out 3 and out 4. We drive both motors forwards using these configurations, such as out 1 and out 3 are set to the high, and for the out 2 and out 4 is set to the low. The L298N use internal transistor, which is caused a 1.8 voltage drop since both a high side and low side transistor are involved. The total internal drop is 3.6 because there is two motors in both. For the motor A, out 1 is 12 voltage at minus with the 1.8 voltage, which will equal to 10.2 voltage are using. And for the out 2 is also minus with the 1.8 voltage. So the voltage across motor A is 8.4 voltage. Same go to the motor B. The out 3 is 10.2 volt, and for the out 4 is 1.8 volt, and then the voltage across motor B is also 8.4.
Hello, my name is Yip Yong, and in this section I will explain the flowchart of our obstacle avoiding robot. The flowchart represents the robot's decision-making process. It starts with system initialization, where the Arduino board, motors, ultrasonic sensor, and infrared sensors are activated. Then the ultrasonic sensor continuously measures the distance in front of the robot. The decision is whether the measured distance is less than a set obstacle limit, and in our case it is set at 15 centimeters, which means if the distance is greater than 15 centimeters, the robot considers the path clear and continues to move forward. However, if the distance is less than or equal to 15 centimeters, the robot executes an avoidance maneuver. It will stop and then reverse and finally turn left or right to avoid the obstacle. After turning, it loops back to recheck the distance and repeats the process. This logic allows the robot to autonomously navigate its environment by avoiding obstacles in real time. Now I will explain how the Arduino code implements the logic shown in the flowchart. First, in the setup section of the code, we define and initialize the pin connections for the ultrasonic sensor and motor driver. Next, we define the movement functions such as forward, back, left, right, and stop to control the motors using a motor driver module. The getDistance function sends a pulse from the ultrasonic sensor and calculates the distance to the nearest object using the time it takes for the echo to return. So we also use a helper function called the getAverageDistance to smooth out the sensor readings by averaging multiple measurements. So this is to reduce errors caused by the environment, such as noise. In the main loop, the robot checks the distance in front. If the path is clear, it moves forward. If an obstacle is detected within 15 centimeters, the robot will stop, then reverse, and then turn left or right, and then it tries to move forward again. So this logic repeats continuously to allow the robot to adapt to obstacles in real time and to keep moving forward without hitting anything. This code is designed to be preliminary, and after multiple tests in real environments, we will improve the robot's behavior by fine-tuning to reduce the delays and possibly optimize the turning angles. And so that is all from me. Thank you.
To sum up our project, we successfully designed and built a low-cost Arduino robot capable of maze navigations and obstacle avoidance. Our robot can think and move by its own by using a combination of ultrasonics and infrared sensor which used to detect walls, barriers, and open paths. Using the data from the sensors, it makes real-time decisions to avoid collisions and choose the correct direction to move, all thanks to the programmed motor control logics. This project was more than just building a robot. It gave us hands-on experience in many core areas such as electronics, embedded system programming, and real-world problem solving. Overall, it supports the goal of practice-based engineering learning. We didn't just learn about the theory, and we also actually applied it in a functional competitive systems, all while staying within our tight budgets of 150 ringgits. That's all from us. Thanks for watching.